So let's have a look at example 12. It says that from a point P, the ship S is sighted 12.4 kilometers away on a bearing of 137 degrees. True. Point Q is due south of P and is a distance of 31.2 kilometers from the ship. Work out the bearing of the ship from point Q. So we first draw a diagram with these word problems. Pull out your trusty ruler to draw those beautiful straight lines. We're working with bearings, so let's draw on the corner our north, south, east, west indicator, just so we know our directions. North, south, east, west. Let's start with a point P. Alright, so point P, and we're heading towards a ship S. So use a ruler, draw in that beautiful straight line from P to S. Oh, that's not straight. Let's do that again. P to S, a beautiful straight line. There we go. What do we know? So P to S is 12.4 kilometers. We also know that it is on a bearing, a true bearing of 137 degrees. So if we drew a mini north, south, east, west indicator on P, then from the north indicator to the line PS, and that's 137 degrees. Okay, what else do we know? We have a point Q is due south of P and is a distance of 31.2 kilometers from the ship. So if we drew a straight line down P to Q, again, make sure you're using a ruler, draw those beautiful straight lines. Let me zoom in and do this. Nope. Alright, let me rub this off and then do this. Nope. Nope. Come on, iPad. Nope. Why won't it? Why is it not auto aligning? Why? You know what? Let me just draw the line. No, that's not straight. Draw the line and let's see if I can lasso to. Oh, there we go. Beautiful. Alright, so let's go P to Q. So that's point Q, which is due south of P, so it's on the north-south line. And Q to S is a straight line. Let's do that again. Beautiful straight line using a ruler. There we go. Which is 31.2 kilometers away from S. What is it that we want to find? We want to find the bearing of ship from Q. So from Q means you're at point Q, you draw in a tiny north, south, east, west indicator. From Q, you want to go to the ship of S, right? So your north, south, east, west indicator, you're going from the north indicator of Q and you're going all the way to hit the QS line. So that is our angle of interest that we want to find, theta over there. Right, so the question is, well, what do we do? What formula can we use to work this out? Well, let's see what we are told. We're given two sides and we want to find an angle. So remember in cosine rule, one scenario which we use cosine rule is we're given three sides, which we don't have because it's not easy to work out PQ right now. So we can't use scenario 1 for cosine rule, so that's out the window. Given two sides and one angle and we want a side, well, that doesn't really apply to us. We don't want a side right now, so cosine rule can be out the window. It's not a right angle triangle, so SOHCAHTOA out the window is probably useless as well. So most likely we want to use a sine rule. Now we want sine rule, we want to look for angles and the corresponding or the opposite sides. So theta is opposite 12.4, so that's one pair of corresponding angle and sides. The angle which is opposite to 31.2 is this angle, green angle, which I'm going to call alpha. right? So if I could work out what that green alpha was, then it's opposite 31.2 kilometers, which then forms a pair, which means I can use the sine rule. So how can we work out green alpha? Well, 137 and green alpha lie on the same line, so they add up to be 180 degrees because of supplementary rule. So because of that, we can work out green alpha, and then we can apply the sine rule to work out what theta is, because that's the angle of interest. Right, so let's solve this by first defining some variables, and then applying the supplementary rule to work out the green angle, and then applying the sine rule. So let theta equal angle bearing of the ship from the point Q. Let alpha be the angle QPS. Now alpha is 180 minus 137 degrees. Why? Because of supplementary rule. Angles on a straight line add to 180, which means it's 43 degrees. And now because we've got two pairs of angles and the corresponding sines, we can immediately use the sine rule. So let's write that down. Using sine rule, default formula, A on sine A is equal to B on sine of angle B. Okay, let's make 12.4 my A. So then my angle A is theta. So B is 31.2 as the distance, then sine of B is sine of the green angle alpha, which is 43 degrees. I'm going to cross multiply, so 12.4 sine of 43 degrees is 31.2 sine of theta, so sine of theta is 12.4 sine of 43 degrees. Make sure you write the degree symbol. Units are very important. Divided by 31.2. Using a calculator, that gets us approximately 0.271. Opposite of sine is sine inverse, so sine inverse of 0.271 gives us approximately 15.73 degrees. Make sure your calculator is on degrees, because the question gave us angle in degrees, not radians. Otherwise you'll get some really weird small answer, and that's not what we want. So let's finish the question with a sentence conclusion. What is the bearing of the ship from Q? So therefore, the bearing of ship from Q is approximately, make sure you round appropriately. Let's do true bearing, 0.016 degrees true. So when you're doing true bearing, it has to be 3 digits long, and because 16 degrees is only 2 digits, you throw a 0 in front. Or if you prefer to go north 16 degrees east. And again, as a habit, because we've used a sine rule, you should always make it a habit to check for, do we have an ambiguous case? So first of all, remember the conditions for ambiguous case. Your given angle is acute. Well, the angle we're given, well, we worked out, is the green alpha. Is it acute? Yes, it is 43 degrees. It's less than 90. Your second condition is your adjacent side is bigger than your opposite side. So my adjacent side is 12.4. My opposite side is 31.2. That's not true. So that's all good. We don't have to work out the ambiguous case. But it's a good habit to always check whether you do